No.
It is.
It is. OK. Hi, everybody. So I missed when you raised your hands to show how many of you know Homer. Oh, OK. That's fine. And this is the reason why I'm here, because I've been working in this area for some time. And by the way, I'm currently working with Nexmo, which you probably know as well. We're expanding the RTC and voice offering, and of course, Kamailio and Homer are involved. The reason why I'm here is that Homer is used for basically in every project I've been working on. And so I thought, since I was contributing small improvements and patches, I thought of being a more stable collaborator of the project. And by the way, so the main subjects in the projects are, as you know, Lorenzo Mangani, Alexander Dubovikov. And you will see Alexander on Wednesday, and with his presentation, and probably around since tomorrow, starting from tomorrow. Lorenzo is online now, so if you want to connect, there will be a live interaction there. So anything related to the workshop as well, you will find him and the rest of the community. And there's also Federico around, and Alfonso's made some contributions to the project. So feel free to approach us and for questions. So the need for Homer, I think it's clear for everybody. We need, when we deploy VoIP and RTC infrastructure, we need to be able to monitor and know what happens. And we have to do it typically with platforms that are experiencing low traffic, a very high load, so we need to deal with it in an efficient way. And the good thing about Homer is that it's already integrated into the main applications in the area. So basically, it comes for the integration with the open source applications that you are probably already using comes for free. We'll see some examples, but of course, Kamailio itself can interact directly with Homer natively. And of course, we have also OpenShips and FreeSwitch and Asterisk and RTP engine, and in some way also Janus. And it would be an interesting case for the future. For anything that doesn't speak natively with Homer, there is Capt Agent, which is a sort of capture agent that can filter and basically packetize the packets for Homer so that they can be consumed even if the application that is producing zip is not able yet to talk directly with Homer. And in some cases, we saw in some installations, the flow was also encapsulated and needed a special treatment, and Capt Agent can do that, can decapsulate the traffic and send it to Homer. We'll also see some examples of something that it's not SIP related, but it's more oriented on the events, like RTCP events and logs that you may want to correlate with the SIP calls anyway when you're doing your troubleshooting. So the key features are that it's an open source project, so it's also very easy to extend and adapt due to the technologies that have been used. And it's relatively easy to deploy. We'll see some examples later on, and can scale with to very high load of traffic. So we can say it's carrier grade. There is also a cloud version for people that perhaps want to try it out, and without having an installation in their premises, they can play with it. They can get more familiar and then decide to go to the hosted configuration. So the applications communicate with Homer, which is the collector and aggregator of information, through a dedicated binary protocol, which is called HEP. And we developed also a dissector for Wireshark. So if you are troubleshooting your platform and seeing HEP traffic, you'll be able to see in Wireshark exactly what's flowing to your Homer installation. So Kamailio is part of Homer as a collector of data, but it's also, of course, the producer of data, in particular for SIP signaling. And the main module are SIP trace and SIP capture. And there is the equivalent for OpenSIPs as well, with a little bit, with an additional management for the specific HEP protocol in a separate way. It comes for free with FreeSwitch as well in the Sophia library. So it just needs to be configured, and the same for Asterisk and RTP engine, and also for SNGrep. So if you're using any of these applications, it's just a matter of configuring them in order to produce data for the capturing tool. For what concerns external support, there has been an interesting project involving Janus, because Janus now has a new events management system, and what we wanted to do was being able to correlate these events with actual calls, while Homer it was designed initially in a more SIP-centric way, let's say. And for anything that is not SIP-specific, with FreeSwitch, by integrating with the ESL, it's possible to get the events, which are many, and can be filtered out and be sent to Homer and be correlated as well. And in a similar way for the CAPT agent and also RTP agent. Anything that is not supported yet by the applications can be seen on the network and can be traced and packetized and sent to Homer. So there is a plethora of libraries that you can use in your clients. So if you want to build your own client, or if you have to modify one, there are several programming languages covered. The protocol per se is very simple. We'll see it later. So it was easy to expand it in various languages. So the architecture is simple. So we have the producers of SIP signaling or other events, which are your applications, and then Homer itself, it's basically one collector of data, which is, in our case, is based on Kamailio, which writes on a database, which could be MySQL or Postgres, and it exposes an API, which can be used directly, but it's typically used through the GUI, which is also part of the project itself. And so being PHP-based, it's easy also to customize the API for any need. And also, it's possible, there are cases where you may want to access the database directly without even passing from the API or GUI. And of course, it's possible because of the technology involved. And since there is Kamailio processing data there, and the logic will be based on Kamailio CFG, as for your applications. So it's also possible to send the data directly to other collecting systems like Elasticsearch, for example. And we saw an example, I think, last year with Kamailio using Federico's HTTP async client module to send data to Elasticsearch for indexing. There can be various types of data. Of course, SIP signaling, but also RTCP and RTCP extended reports. And plus also quality of service reports that are sent by some applications at the end of the call, and WebRTC and ISUP events. All these can be correlated, provided with the correlation ID, which is typically the call ID. They can be correlated in one single entity. So for each call, you will be able to search what happened and see the correct and the exact SIP signaling and SDP with the precise timestamps, so you can basically troubleshoot what's happening in your platform or identify a specific call that had a problem. And you can also have RTCP reports correlated to the same call. So you will have a decent idea of what was going on during that call, at least how provided by the applications that were producing data. Another interesting thing is that, so you know that there could be a logical call in your platform that it's in fact more than one SIP call. So what Homer can do is it can correlate these legs into one single logical call. And this is achieved by transporting the call ID from one leg to the other via a configurable custom SIP header that you can strip afterwards, of course. So this is how the search result appears typically, but we'll see it directly. So basically, you do a search and you have a bunch of results. And these are, they have the method, the accurate timestamp, and a few other information, in particular the call ID, which can help you to identify specifically the call you were interested in, and also the user agent that was producing that data. And this is how a typical, very simple call flow appears. So you can see that there are the main actor. In this case, the producer was the component in the middle. And if you click on a message, you can get all the details of that specific message, and including the SDP. We'll see it live. I think it's more interesting. Am I going so fast? Yes. And one thing that it's, I think, changes most of the interaction between the developers and the support teams typically is the collaboration tools that Homer makes available. So basically, once you have identified one call or one set of legs that you are interested in that may have had a problem, it's possible to share this information to your collaborators, and you can extract a pickup. So basically, Homer will build a pickup for you, or extract the picture with a call flow, or even just sharing a link so you can send it via Slack or any other method. And granted, the receiver will have access to Homer. It will be able just to click on the link and see what you are seeing. So this is an extremely useful collaboration tool. Since Kamailio is the consumer of the data, and it's possible to customize its behavior. So there is a standard behavior that comes out of the box with Homer, but then you can customize it, and you can extract the statistics that you may need, since you have everything available. And you can do projects like Alfonso over there did a modification of Homer so that you could have a sort of reporting of error codes divided by country. So you could have a dashboard with the error codes divided by each country, so you could monitor specific destinations and identify spikes of errors and then go deeper and investigate, which was extremely useful. And of course, there are the statistics that are collected by Kamailio as long as the data comes in. Kamailio adds information on the statistics, and then based on specific thresholds that can be set, there are alarms that can be triggered, and for example, by sending an email to a specific collector. So for Homer, the Kamailio has a key role, which is the consumer of data, and so plays two parts: the producer of data, and also the consumer. And for what concerns the consumer, the key point is that it must be a very fast consumer of data, but also writer of this information into the database, together with performing computation on statistical components and possibly even alarms, or do something very specific like getting the data, not just send it to MySQL, but also transfer it to an Elasticsearch system. This is, for example, I think it's the core configuration for a Kamailio inside Homer. So it just needs basically to know where to listen and what credentials to use to write into the database. And SIP capture is the module taking care of this. And what it's possible to do is, depending on the type of message, on the method, for example, zipcatcher will select a specific destination table or another. So you can have all the calls in one table, all the registrations in another, and all the other requests like options in a separate table, so that you can have a division, a separation of the data. This is an example of configuring zipcatcher, which will inherit the MySQL credentials and will be configured to use the HEP protocol, and then with some configuration items for managing the interaction with the database. This part, I think it's the part that makes some value in practice, because so when you're going to do your own deployment, you will face in large deployments, you will have to deal with high loads. So granted that there can be high performances achieved by one single machine, the typical solution is the one that you probably apply also to your VoIP platform, which is dividing the traffic in multiple nodes. And this can happen at different levels. It could be multiple Homer nodes or multiple MySQL nodes, or anyway, the DB that you're using. And in other cases, you may have constraints like it happened to me, and you cannot make data flow from one data center to another. So you want to keep the data local in the data center. So the producer will produce in the local Homer, and then the GUI will be able to search the overall cluster of databases. Or other approaches at a lower level, which, for example, Paolo has been experimenting with, doing UDP level load balancing, so that the flow of UDP packets that carry HEP data are load balanced among a cluster of Homer machines. In fact, Kamailio machines, by doing load balancing at UDP level, so agnostic from what's actually transported. This is very simply the approach across data center. I think the main point here is that the API and the GUI can query more than one DB at the same time, and you will have the information aggregated all together, even if the data is separate. So it may be separate because you have a design constraint, or for perhaps even legal reasons, so you can keep the data locally and then query it remotely and correlate it. Or you can do something like sharding by using the capability of Kamailio to use different MySQL servers, depending on what type of traffic it's seen. It could be made based on call ID or based on method of the request. And this is another technique to improve the overall capacity. For what concerns deployments, so there are various strategies to deploy. Typically, I find something different in every case that I work on. And so in general, there is a very nice bash script which works for, I think it's mainly to get you started. So you can have everything in one single box with a bash installer. And you don't need to do any particular customization. And this works fine, but doesn't necessarily cope with your current deployment system. So there is another method that is based on Docker, because the modularity of Homer works well with the way of separating the services into containers. And you can have, in fact, you could even have a Docker container with everything inside. And you have your image with Homer. You can carry it wherever you want and use it. Or there is the multi-container approach where each service has its own container. And we'll see it live. For who's more keen in using configuration management tools like Puppet, there is a module. And you can use it with a master, or you can use it even in standalone. You don't really need a master. And what I've been using it, I use it to install everything directly on the boxes, but also I use Puppet to manage the Docker containers. So it could be a way of integrating the two things. So if you have enough freedom to use containers, but still you have the constraint of using Puppet in your infrastructure, you can use the module to orchestrate the containers as well. And of course, it opens the possibility to any other orchestration system like Kubernetes, whatever that can deploy the containers for you. Another typical case that I see is that where you want to deploy Homer, the DBA team typically says, well, this is going to be a DB, so we are going to take care of it. And this is perfectly fine, and it typically works. So you can delegate the management of the database to another team, and the interaction will be absolutely standard. There are no specific customizations. And you can configure Homer. In particular, the container, in the container version, you can configure it so that it won't even generate the MySQL container for you. So the bash installer, I think this may apply for a dangerous demo, James, right now, I mean. So the minimalistic installation that I mentioned is with a bash installer. And so I'm going to, I have already everything installed in this machine, 113. So this is a Homer instance already running on a DigitalOcean box. And I placed some calls earlier on. And we can see the dashboard with some overall information. I made a search there using a call ID, which I'm going to do again. Perhaps not in the last 30 minutes. Well, let's see everything now. OK, so this is a typical search result. And if you click on a call ID, you will have some information about that call. So I didn't bother here, but these IP addresses and ports here, of course, you cannot do it for the clients. But for your own components, there is an alias table in the database by which you can associate IP addresses to ports. So when you see something like this, rather than seeing the IP address and port, you will see a service name, possibly with an information on the data center. Let's see if I... So what I want to do is I want to kill this machine and reinstall it from scratch. This is why I think it may apply as dangerous demo, but I must admit I've done it already. So I'll rebuild it. So now it's going to destroy completely that machine and rebuild it. Rebuilding it so quickly, the IP address will be saved, so I won't have to change the configuration. But now, right now, you can see that there is no access anymore to that Homer, which is all gone together with the data. So now I'm going to use the bash installer to start from scratch. think it's visible. Okay. Sorry. Extra security. Right, so is this sufficient in terms of sites even over there? Cool. So if I get the bash installer from here, I'm just going to run it. It will just take some time to do the installation, and then I will provide the MySQL credentials. OK, so it will take a couple of minutes. So meanwhile, what we can do is we can start talking about the Docker installation. So the nice thing about this is that it's based on Docker Compose. So there is one single file defining the services and the interaction that the services have one to another. So if we go to look into the Docker Compose file, you may probably see that there is the definition of the services. There's the web app, which contains the API and the GUI, a cron container for anything that is related to managing the data in the database. Because, of course, you can imagine the huge amount of data that is created continuously in your platform. So all that needs to be rotated. It's configurable. It's typically rotated daily. Of course, it's configurable, and this container takes care of it. There's, of course, a Kamailio service, which is the collector of information. And of course, so what I did in other cases were having more than one container with Kamailio. So basically, that's another scaling strategy where if you are using Docker, you can have many containers, each one with a Kamailio, and then one separate MySQL DB, which may be running on Docker as well or not. But you basically use the modularity of Homer to adapt to your scaling issues. OK, so let's generate the SSL certificates. And this will keep going. Meanwhile, I'm going to connect to another machine where the Docker installation has been done. So we can start seeing the how it looks like. It looks like with Docker. OK, so with a Docker PS, there are no running containers, but because they just been. OK, there are no containers at all. Funny. I'll have to rebuild the containers, but it's part of the workshop anyway. Okay. OK, so being managed by Compose, we can just run everything with Docker Compose app -d. Then we'll have the containers running. So a Kamailio, a web app, a cron, and and MySQL. Docker Compose will generate a dedicated network for it as well, so that the containers can address each other by using the name rather than you needing to know the IP address. And for example, if you are going to see the Kamailio, some internals about the Kamailio container, we can see that it's listening on UDP 9060 because this is where HEP will be received, and then it's linked with the MySQL container. This is pretty straightforward. Okay, so credentials for the bash installer. Hopefully. Okay. Oopsie. This is why I said it was a dangerous demo. What's going on?
Just a practice run, clearly. Real thing. Practicing for your crash and burn prize.
Yeah. Okay, something was clearly wrong here. Okay. I don't know, I may have lost connectivity in the middle, but I don't think so.
Yeah, the network's not good at the moment.
No, I don't think it's the network. I'll focus on the other one then for now. So let's try to use the container-based version. Right, with the default credentials here. So this is the one running on containers. And this is a little detail on how to configure the container version without also involving a MySQL container. Just provide user remote MySQL true into the Homer env, which is the Docker Compose environment file. We saw the containers in action. The Puppet module, I won't show it, but so it runs on Ubuntu and CentOS as well. There are small changes in terms of PHP libraries. And there are various parameters, but the main one, this is an example of the minimum information that you can provide to your Puppet agent or Puppet master. You basically define a user ID and password for, well, even just the host and the password for the Puppet module, and it will install everything for you. The advantage of this is that it provides support for Ubuntu as well, and it's very easy to customize and maybe reuse quite easily in your platform if you're already using Puppet. Okay, now before this, I wanted to show you Kamailio live as producer with a very simple configuration. So we'll go into this machine. Okay, where Kamailio is running. But since I'm going to use a different Homer host in respect to what I planned, I'm going to edit Kamailio's configuration. So in this case, it's the zip trace module that is the main element. And I'm going to, into the duplicate URI, I'm going to set the IP address of the Docker-based Homer. Few configuration here. We are just saying we are just telling zip trace not to trace on the database because it was initially designed for that. Use hep instead, and we set a flag so that we can make a correlation between a transaction and the responses to the same transaction. So in this case, you see it's very a minimal installation. We just trace everything. We send everything to Homer, and just for the invite we just reply a 403. But I need to restart. I need to restart it. Like this, and then perhaps, yeah, can grab. So I'm going to send an invite to this machine. Which is 196. This one. So very simple invite here. So I got the forbidden directly from Kamailio, and this is the this is what happened basically. So there was an invite coming in to port 5060, and as soon as it came in, it was put inside a HEP version 3 packet and sent to Homer. You can see the very first part of the trace is the binary headers that the HEP packet is carrying, which are then used by Homer to fill the information into the database. So we can see the forbidden has been sent as well, and the ACK as well. So in Homer, in the last 10 minutes, hopefully, okay, well. Okay. A typical problem with different time zones in machines. So we can see basically the code flow with what we just sent to that Kamailio machine. So this is zip, and then we can go and see exactly the message, and it contains the full UDP. Sometimes these invites with SDP may become very large. The default limit is 1,500K, but it can be changed. It can be increased in the rotation ini configuration of the database. In this case, we don't have any quality of service report, but we are going to do another dangerous demo with free switch in this case. Just before that, so with Kamailio 5, there were a few improvements. One was a full HEP version 3 support, which means that the timestamps are more accurate, and it is, in fact, the standard for now. And there was, in fact, Camille Udo added a very useful command to the zip trace module so that you can send directly log lines from Kamailio to Homer without any external application. So this is an example of something that we saw live already. So FreeSwitch as producer, as mentioned, support for Homer comes for free. It's just a configuration item in Sophia. And the tricky part with FreeSwitch is that in most of the cases, you'll be probably using it as a back-to-back user agent with two different call IDs for A leg and B leg. So granted, FreeSwitch can take the call ID from A leg and put it inside a custom zip header for B leg, then it will be available for Homer and there will be the correlation. So we'll see one single call flow. So I have a FreeSwitch machine somewhere here. Which I think is already running. Okay, but I need to change the configuration because I changed the reference for Homer. So again, this is generic Sophia configuration, but it's more flexible than this. In particular, you can define your configuration per profile rather than globally for everything involved with Sophia. And also, you can switch on and off Homer for FreeSwitch on selected profiles. So for example, it happened to me that Kamailio was producing data to Homer, but sending traffic to FreeSwitch. So the A leg, the incoming leg to FreeSwitch was already known by Homer because it was produced by Kamailio. And I just wanted the B leg, the outgoing leg from FreeSwitch to be visible. So I switched off the capture in the internal profile and on in the external profile. The IP address of Homer is this one. Let's put it here. And then we'll go to the FreeSwitch CLI and we reload Sophia. And then I will we'll connect to this FreeSwitch and I will send some traffic there. Let's see if we can see it live as well. 5060 or port 9060. Okay, so we see the buy. So in this case as well, FreeSwitch just with a little configuration is sending data to Homer. Let's see what's visible here. Okay, and we see also the call that ended up into FreeSwitch. In fact, this is a slightly more interesting call flow. And one information that I think is useful here is that we can see the user agent. So it's easy to identify which component was producing something, and may be useful also if you are debugging specific clients or to identify specific FreeSwitch versions, for example. So now, as mentioned initially, we want more than just zip signaling from FreeSwitch. So I'm going to also send some non-zip events that will be correlated to the same call. To do this, I'm going to use HubPipe, which is a Node.js application. It's very simple, but it's also flexible because it has a few different modules, and each one covering a specific need. So you can see here, for example, the ESL client is a module that connects to FreeSwitch event socket, while the HEP client is the one responsible for communicating with Homer, and there is also a Janus client which is delegated to connect into Janus, get events, and again sends them to Homer. For the sake of this workshop, we'll see a simple configuration, which is just this one. The HEP config, of course, means indicates where Homer will be found. And again, I need to change this to adapt to the current Homer machine. Like this. And then the second part is the ESL configuration. So the event socket exposed by FreeSwitch, and which needs specific configuration to be able to be used. So HEPpipe will need to have the right password, but also potentially you can set specific ACLs so that you can limit access to the ESL to local applications, like in this case. So then it's just a matter of running HEPpipe. So in this case, HEPpipe is connected to the FreeSwitch event socket, and it has subscribed to a few types of events. Let me show you which ones. So there are 3 types of events. So call generically, so it's everything that is happening inside a call, but also RTCP. So every 4 or 5 seconds, FreeSwitch may exchange RTCP reports, and these generate events that are visible to subscribed clients, like in this case, HEPpipe. So in this case, we have enabled everything. So call events is basically SIP. RTCP is RTCP reports. QoS is end of the call reports, which may happen in some cases with a summary, for example, of the packet loss or even a MOS score. So in this case, we have enabled everything. We're going to launch the application and then place again that call. So you can see here that so we can switch it off. You can see an example here where an event like the hang up event that the event socket has provided to HEPpipe has been packetized into a HEP packet and sent to Homer. So this is a hang up event, for example, which I think it's interesting because then you can see not just what SIP was flowing between the entities, but also what was the perception of FreeSwitch for that call and what was the direction of the hang up. And another interesting event is this one, which is a summary of the call stats, QoS stats of that specific call with a correlation ID. And this correlation ID is basically the call ID that Linphone used to place the call. So if everything was fine, going into Homer again, we should see now an additional call, which is probably this one, 041, 041. So in this case, we still see the SIP signaling, but also we have the logs of the entire call as provided by FreeSwitch, which can prove extremely useful while debugging, and also sort of quality of service report. In this case, we had a sudden rejection of the call because of a problem, but anyway, you can see that you may have seen a summary of the packets received or lost, and even a sort of most computation. As mentioned before, so the export thing is the most useful. So everything that is SIP signaling can be exported into a pickup file, so that you can then share it with somebody. This is, for example, the extracted SIP signaling directly for Homer. And you may imagine how useful it is to just send this rather than other information, or having the need to do live capturing rather than being able to look in the past. So I think this is the main selling point. Talking of Wireshark, so we developed a dissector so that when you have HEP traffic flowing in your network, you can also trace it and check if everything is fine. And this is also useful to learn how HEP works. In this case, this is a HEP packet carrying SIP. You can see the information that it's carried, source and destination IP addresses, an accurate timestamp, and possibly even an authentication key, because you can work at this level by limiting who can produce the data to your machine. And of course, a correlation ID, which will be used afterwards to do the correlation with other type of events. And for free, you get also all the actual SIP signaling, SIP message, as it was seen directly by Wireshark. So you see everything. And an example of HEP carrying logs. What changes is the type, the protocol type, and of course the payload, rather than carrying SIP message, carries logs. And another example of payload, in this case, it's an RTCP report as seen by Homer and correlated to the same call. So I mean, this shouldn't be needed in normal situations, but if you are curious about what you are observing in Homer in respect to what you see on the network, it's very useful. And also, if you want to get into development and extend any functionality, maybe an interesting, useful development tool. You can export of course, you can export a picture with the call flow. It's probably going to another screen, but okay, it's preview playing with me. But there is a picture with the call flow, and you can also get a link. In this case, it's not configured, but you can copy the link address and then send it over email or Slack. So these, I won't show CaptAgent, but you may imagine a similar approach with CaptAgent, where instead of configuring your application, you install and run CaptAgent on the machine that you're interested in. And through configuration, there are several modules. You can isolate SIP or ISUP or RTP reports, and can also apply sharding techniques with CaptAgent by sending some type of traffic to one Homer instance or another one. So I think I managed to go to everything that I wanted, and I'd like to leave some time for questions. But so in terms of conclusions, I think you'd be interested in the future of Homer. In this presentation that are linked here, by Lorenzo. I think it's very interesting because it's basically moving from a SIP-centric approach to a more event-agnostic approach, where basically you can send every type of event, and the new Homer, which will be called HAPIC, will be able to do a correlation between these events and also graph the events, trying to get the relationship between the producer and the consumer of the data. So I suggest you see this presentation. Also, Pastache will be a generic purpose Node.js application which will replace HAPIP. It has a similar approach, but it's different in the internals, and it will be developed in the future. And on Wednesday, there will be Alexander presenting his distributed system for blacklisting and fraud prevention, which I suggest you will attend. And I think, well, thanks, first and foremost, Lorenzo and Alexander, but also Federico, and Doug Smith, who's the main author of the container part of the multi-container approach. And that's it. So any questions?
Here, okay.
I can guess at least one.
Can you please point more on QoS and how it's related to actual call quality that is known to MOS? And is there any, for example, on the vanilla Homer, make it like if QoS and if the call quality on the certain, let's say, destination goes bad, to raise some kind of event to receive emails and something like this? Yeah.
Okay, so the question was about the relationship with QoS and whether there is any type of alarm that can be set when there is a specific quality of service condition, like, for example, a bad MOS. So without interacting directly with RTP, what Homer does is it gets events related to RTCP reports and end-of-call reports from the various components. So for example, FreeSwitch can forward all the RTCP reports, and then Homer will generate the statistics for you, and you will be able to see them. But also at the end of the call, for example, in particular, if you use some codecs like Opus, you have a summary at the end of the call in terms of packet exchanged, and also when FEC was involved, for example, and an overall MOS estimation. But all this is done not looking into the RTP, by getting the information that the application is seeing. In this case, for example, FreeSwitch. There is a sort of extension of Capt Agent, which is called RTP Agent. In this case, this is a commercial solution that Alexander developed, and this is able to see the RTP as well. So, and it's able to make computations on the RTP in terms of packet loss, doing the correlation live. And then I'm pretty sure, but you will need to ask Alexander, I'm pretty sure you can set up thresholds to send alarms. And all this happens without actually storing the RTP for security or low reasons, but by looking at the RTP live. So RTP agent probably is something you will want to take a look at.
Okay, other questions? Hi. I'm quite interested on the API part. I, for instance, want to know if we can get all the statistic information you show on the main web interface to be used like inside my own interface. Is that possible?
Yes, I think it's possible. Yeah. The API is very simple, and also it's. I wonder if I can see it live. So for example, say, just give me a sec. I'll try to see it live. It's a very simple API, and I'm pretty sure you can see that because the GUI is just using that, so it's not accessing the data directly. So there are these widgets that you can plug and play into the dashboard, and each one has its own set of queries. So by looking at that,
for instance, if I want to render my SIP diagram, I could do it by asking the API, right?
Yes.
And all the other widgets that you are using right now.
Yes, definitely. Yeah, there's nothing that the GUI is doing without passing through the APIs.
Okay, perfect.
So one easy thing would be, doing what I'm doing and reverse engineering the API by grabbing it. And you can see, for example, is it the response? Let's see if I can get the request. There is a lot of information exchanged, but because I think
just install Homer to grab Homer and
yeah.
Yeah. One other question regarding Elasticsearch and everything. That's the new part coming, right?
Well, in fact, that's already available. We can offline. I can provide you with some information. It's already available. It's basically a modification that you can do in the Kamailio that is installed inside Homer. And basically, what you do is you will have your Elasticsearch endpoint. You have to get the data and perform an HTTP request, possibly to Elasticsearch. And so to do this, the Federico's module, which is the asynchronous HTTP client, can be used. So that basically you can place several HTTP requests in parallel without blocking the workers, and you can continue processing the other traffic.
Okay, thank you.
Okay. Last question, or
I have a question about the quality of service. Is it available here? Is it available to have that information for peer-to-peer calls? I mean, we're not having RTP engine. How do you get those information?
Information of peer-to-peer
Quality of service.
Well, that information, as I described, comes from the components that are in the middle. So you have typically two choices. Either you get that information from FreeSwitch or, for example, Asterisk, and Janus as well. Or you can put capt agent somewhere, capt agent and RTP agent somewhere that sees the traffic. If you say it's peer-to-peer, but I imagine there will be the traffic visible on some machine, which could be mirrored, for example, then you can use capt agent and RTP agent to get the same information.
Mm-hmm. Okay, thanks.
and I know that in the past, I haven't checked it now, but some phones, they send the buy with the header, and I know that they process that offline, but it's not real-time feedback on the quality at the end of the call. There is a special header with a summary of communication, like how many packets lost and so on. I think Cisco does it and so on. And then could be properly peer-to-peer communication. But again, you get these reports at the end of the call through the signaling. Yeah. Okay, thank you, Giacomo.
Thank you.
Yeah.